We are going to start now lecture 12 of chapter 9 class 11th mathematics sequence and series. So in this lecture we will study how to calculate the sum of some special series. So the first we have is the sum of the first n natural numbers. So we are talking about the sum 1 plus 2 plus 3 so on up to n. Clearly this is an AP. The first term is 1 and the last term we have it is n, and the common difference we have it is equal to 1. So the sum of n terms, it is given by n by 2 into first term plus last term is n. So the answer we are writing, the formula we are saying, it is sum of k is equal to 1 to n. It means we are talking about 1 plus 2 plus 3 so on up to n. This is equal to 1 by 2 n into n plus 1. So this is the sum of first n natural numbers. Now the next formula we have, it is the sum of the squares of the first n natural numbers. It is equal to 1 square plus 2 square plus 3 square so on up to n square. It is equal to 1 by 6 n into n plus 1 into 2n plus 1. So suppose we are saying that this sum Sn is equal to 1 square plus 2 square so on up to plus n square. Now let us consider the identity. It is k cube minus k minus 1 cube, that is equal to 3k square minus 3k plus 1. Now if we substitute different values of k in this identity, we are talking about, we substitute k is equal to 1. We obtain 1 cube minus 0 cube, that is equal to 3 into 1 square minus 3 into 1 plus 1. Next, if we substitute the value over here, it is k is equal to 2, we get 2 cube minus 1 cube, that is equal to 3 into 2 square minus 3 into 2 plus 1. Next, if we substitute 3, it is 3 cube minus 3 square is equal to 3 into 3 square minus 3 into 3 plus 1. And likewise, if we continue, the terms we have it over here, it is n minus 1 cube minus n minus this is 2 cube over here, this is n minus 2 cube, it is equal to 3 into n minus 1 square minus 3 into n minus 1 plus 1. In the last term we will have it is n cube minus n minus 1 cube, that is equal to 3n square minus 3n plus 1. Now if we add all these terms, we can see this 1 cube gets cancelled, this 2 cube gets cancelled, this 3 cube will get cancelled, and likewise all these terms get cancelled, and we are left with is n cube, and that is equal to, now look at this first column, we can take 3 common and we can write this is 1 square plus 2 square so on up to plus n square. From this next term we can take 3 common, it is 1 plus 2 plus 3 so on up to n, and last term we are saying it is 1 is being added n times, so we are saying this sum is equal to n. So by adding these terms we are obtaining n cube is equal to 3 into, it is sum of these terms, we are writing it is Sn, minus 3 into sum of these terms, it is 1 by 2 n into n plus 1, and last it is plus n. Now we want to calculate the value of Sn, so we are writing 3 Sn is equal to, it is n cube plus, this is 3 by 2 n square plus 3 by 2 n minus n. Now we are saying, if you look at these two values, it is 3 by 2 n minus n, this value comes out to be 1 by 2 n. So what we are getting is that Sn, that is equal to n cube plus 3 by 2 n square plus 1 by 2 n. Now if we write 1 by 2 common, we are left with is 2n cube plus 3n square plus n. So this is equal to 1 by 2 into this value we can write n common, we are left with is 2n square plus 3n plus 1. So the value of this implies us that the value of Sn we have it is n by 6 into n plus 1 into 2n plus 1. These are the factors of this term. So this is the sum of the n terms. This is the sum of these n terms. So this is the formula for the sum of the series 1 square plus 2 square plus so on up to plus n square. Now next is sum of the cubes of the natural numbers. So we have to calculate the value of, we are saying Sn is equal to 1 cube plus 2 cube so on up to plus n cube. Now to solve this we are using the identity that k raised to the power 4 minus k minus 1 raised to the power 4 is equal to 4k cube minus 6k square plus 4k minus 1. Now if we substitute different values of k in this and we add those values, we are getting 1 raised to the power 4 minus 0 raised to the power 4 is equal to 4 into 1 cube minus 6 into 1 square plus 4 into 1 minus 1. Next we obtain it is 2 raised to power 4 minus 1 raised to power 4 is equal to 4 into 2 cube minus 6 into 2 square plus 4 into 2 minus 1. Continuing in this way, we are writing n raised to the power 4 minus n minus 1 raised to the power 4 is equal to 4 into n minus 1 cube. This is n cube, then minus 6 into n square, then plus 4n minus 1. Now again if we add all these values, we will obtain that this term gets cancelled. So we are left with this n raised to the power 4 is equal to 4 times Sn minus 6 into sum of squares, its value is 1 by 6 n into n plus 1 into 2n plus 1. Then it is plus 4 into sum of these terms, it is n by 2 into n plus 1, and last it is minus n. So we are saying what we have obtained from this, we are writing it n raised to the power 4 that is equal to 4 times Sn minus n into n plus 1 into 2n plus 1, then minus 2n into n plus 1. This term is with plus sign, and then it is last term it is minus n. So we are writing 4Sn is equal to n raised to the power 4 plus, if we multiply these three terms, we obtain it is n square plus n into 2n plus 1 plus this term will become minus, it is minus 2n square minus 2n plus n. This is equal to n raised to the power 4 plus 2n cube plus n square plus 2n square plus n minus 2n square minus 2n plus n. So this 2n square gets cancelled, and this 2n gets cancelled, and we are left with this n square into n square plus 2n plus 1, and this is equal to n square into this value we have, it is n plus 1 whole square. So finally we have obtained from this result, we are saying finally we have obtained that Sn is equal to 1 by 4 n square into n plus 1 square. This thing we can write it is 1 by 2 n into n plus 1 whole square. So this is the sum of 1 cube plus 2 cube so on up to plus n cube. Next is the sum of the cubes of first n odd natural numbers. So we are talking about the sum 1 cube plus 3 cube plus 5 cube and so on up to plus 2n minus 1 cube. So we are writing, suppose this sum is Sn. So we are writing Sn is equal to sigma k is equal to 1 to n 2k minus 1 cube we can write this is equal to sigma k is equal to 1 to n. This value we have, it is 8k cube minus 12k square plus 6k minus 1. It is finite sum, so we can write it is 8 sigma k cube, k is equal to 1 to n, minus 12 sigma k square, k is equal to 1 to n, plus 6 sigma k, k is equal to 1 to n, minus sigma 1, k is equal to 1 to n. Now we know the formula for all these terms. This is equal to 8 into 1 by 4 n square into n plus 1 square. Then it is minus 12 into 1 by 6 n into n plus 1 into 2n plus 1. I think this value it is 2n plus 1. Then it is plus 6 into 1 by 2n into n plus 1. And last term we are having it is sigma 1. It means 1 is being added, 1 plus 1 plus 1 so on up to n times. The answer for this we have it is minus n. Now if we solve all these values, if we try to solve all these values, we obtain this gets cancelled, we are left with 2, this gets cancelled, we are left with 2, this gets cancelled, we are left with 3. So we are having over here 2n square into n plus 1 square minus 2n into n plus 1 into 2n plus 1 plus 3n into n plus 1 minus n. And if you open all these brackets, the final answer you will obtain, that is n square into 2n minus 2n square minus 1. So we are saying that the sum of the cubes of these odd numbers, it is n square into 2n square minus 1. So we have listed these formulas over here. We are saying the first we have studied, it is 1 plus 2 plus 3 so on up to n, it is 1 by 2 n into n plus 1. Next it is 1 square plus 2 square plus 3 square so on up to n square. The value it is 1 by 6 times n into n plus 1 into 2n plus 1. Third, the sum of the cubes, it is given by this formula, 1 by 2 into n plus 1 whole square. And if we are adding the odd values, we are having the result, it is n square into 2n minus 2n square minus 1. So these are the 4 formulas that we have derived. Next we have is, if S1, S2, S3 are the sum of first n natural number, their square and cube respectively, we have to prove this result, that is 9s2 square, that is equal to S3 into 1 plus 8s1. This is the relation between these 3 sums. So to prove this result, we are saying the value of S1 we know, that is equal to 1 by 2 n into n plus 1. The value of S3 we know. So if we multiply both these results, we are saying S3 into 1 plus 8 times S1, that is equal to 1 by 4 n square into n plus 1 square into 1 plus 8 times 1 by 2 n into n plus 1. These two terms get cancelled, it is 4 over here. So what we obtain is, we obtain 1 by 4 n square into n plus 1 square into, look at this term over here, it is 1 plus n square plus n. This value we are having, it is 4 over here. So we get it is 4n square plus 4n, and this is the value for 2n plus 1 whole square. This is the value of 2n plus 1 whole square. Now, if we write the value of 9s2 square, the answer we have, it is 9 by 6 n into n plus 1. This is square over here, square over here, square over here, and 2n plus 1 square. So we get, this is, these two gets cancelled, we are left with this 4, and we can clearly see that both these values, these are equal. So we are saying this is the left hand side, this is the right hand side. So we have proved that LHS is equal to RHS. Both these values, these are equal. Next is find the sum to n terms of the series whose nth term is n into n plus 3. So we have to calculate the value of sigma. K is equal to 1 to n. It is k into k plus 3. We can write this is equal to sigma k is equal to 1 to n k square plus 3k. So this is equal to sigma k is equal to 1 to n k square plus sigma k is equal to 1 to n 3 times k. Finite sum is there, so we can separate the sums and we can take this 3 common. So the values we have over here, the sum of the first square of first n natural numbers, it is 1 by 6 n into n plus 1 into 2n plus 1, and this is 3 by 2 n into n plus 1. So if we write 1 by 6 n into n plus 1 common, we are left with is 2n plus 1 plus 9. So this is equal to 1 by 6 n into n plus 1 into 2n plus 8. So this 2 gets cancelled over here and the answer we are left with is 1 by 3 n into n plus 1 into n plus 5. Next is find the sum of the series whose nth term is this. So again we are writing Sn is equal to sigma k is equal to 1 to n 2n minus 1 square. We are writing this is sigma k is equal to 1 to n 4n square plus 1 minus 4n, or in place of n we are writing k over here. So again the sums we have over here, it is 4. Sum of squares, it is 1 by 6 n into n plus 1 into 2n plus 1. Then we are saying we are adding this one n times, the answer we have it is n, and then we are saying it is minus 4 sigma k, so it is minus 4 1 by 2 n into n plus 1. So on solving this, the answer we are getting it is 2 by 3 n into n plus 1 into 2n plus 1, then minus 2n into n plus 1, and last it is plus n. Now if we write 1 by 3, we are writing 1 by 3 common from whole of these terms. We are left with is 2n into n plus 1 into 2n plus 1 minus 6n into n plus 1 plus 3n. Now if you solve, open all these brackets, if you will open all these brackets and simplify these terms, you will obtain the answer in the form 1 by 3n into 4n square minus 1. Next is find the sum of n terms whose nth term is this. So we have to calculate the value of sigma n square plus sigma 2 raised to the power n, or we can write it is sigma k is equal to 1 to n k square plus sigma k is equal to 1 to n 2 raised to the power k. Now sum of these values, the sum of these values, it is 1 by 6 n into n plus 1 into 2n plus 1, and the sum of next values we have it is 2 plus 2 raised to the power 2 plus 2 raised to the power 3, so on up to plus 2 raised to the power n. This is a GP with first term a, common ratio 2, raised to the power n minus 1 number of terms over 2 minus 1. So the answer we are getting in this case, it is 1 by 6 n into n plus 1 into 2n plus 1. This term gets cancelled and we are left with this plus 2 into 2 raised to the power n minus 1. So this is the sum of the n terms of the series whose nth term is n square plus 2 raised to the power n. Next is sum the series 3 into 8, 6 into 11, 9 into 14, so on up to n terms. So we are saying that if we write the general term for this series, we can write the tk, that is equal to kth term of 3, 6, 9, so on, into kth term of 8, 11, 14 and so on. So we can write this is equal to, this is 3, 6, 9, this is an AP. So the first term is 3. We are writing the kth term, it is k minus 1 into the common difference is 3 into, this is an AP, the first term is A. We are writing k minus 1, the common difference over here it is 3. So if you solve this, you will obtain it is 3 plus 3k minus 3 into 8 plus 3k minus 3. So we are getting the answer, it is 3k into this value we have, it is 3k plus 5. So we are getting it is 9k square plus 15k. Now we have to calculate the value of sigma 9k square plus 15k. We are writing the answer, it is 9 into 1 by 6 n into n plus 1 into 2n plus 1. Then it is plus 15 into 1 by 2n into n plus 1. We are talking about, we have obtained this result over here. It is 9 into 1 by 6 n into n plus 1 into 2n plus 1. This term we are talking about. Plus 15 into 1 by 2n into n plus 1. Now on solving these values, we obtain the final answer in the form 3n into n plus 1 into n plus 3. So we are saying that the sum of this series is 3n into n plus 1 into n plus 3. So this is the final answer in this case. Next we have is 1 into 3, 2 into 3, then 2 into 3 into 4, then 3 into 4 into 5, so on. So if we write the general terms over here, the first term we have it is 1 over here. So we are writing it is 1 plus k minus 1 into 1 into the second term we have it is 2 over here. So corresponding to this 2 we have it is 2 plus k minus 1 into 1, and corresponding to this third term 3 we have 4, 5, 6 like this. So we are writing it is 3 into k minus 1, 3 plus k minus 1. So we are writing it is k into k plus 1 into k plus 2. Multiplying these terms we obtain it is k cube plus 3k square plus 2k. So our question becomes that we are calculating the value of sigma k cube plus 3k square plus 2k, and k is varying from 1 to n. Now the values of this term, it is 1 by 2 n into n plus 1 square plus 3 into 1 by 6 into n plus 1 into 2n plus 1, and last it is 2 into 1 by 2 n into n plus 1. Now from these two terms this gets cancelled. We are left with this 2 over here. So answer we are getting it is 1 by 4 n square into n plus 1 square plus 1 by 2 into n plus 1 into 2n plus 1, and last we have it is n into n plus 1. Now if we write 1 by 4 n into n plus 1 common, we are left with is n into n plus 1. Next term it is 1 by 2 into 2n plus 1, and next we have it is plus, from this term we are left with is plus 4. This term it will be 2 over here. This is not 1 by 2, this is 2 over here. So when you solve these terms, this is n square plus n plus 4n plus 2 plus 4. So the final answer we are getting, this is equal to 1 by 4n into n plus 1. On solving this we will get it is n square, this value we have it is n square plus 5n plus 6. So it is n square plus 5n plus 6. So this is the sum of these series up to n terms. Next is find the sum of this series. It is 1 square plus 3 square plus 5 square and so on up to n terms. So we are saying, if we look at the general term over here, we are talking about tk. It is 1 plus k minus 1 into 2 square. We are talking about 1, 3, 5, so on. This is an AP, and the terms of this AP they are given by 1 plus k minus 1 into 2, and the power over here it is 2. The power over here it is 2. So we are writing it is equal to, when you solve this value you will obtain 1 plus 2k minus 2 square. So this is equal to 2k minus 1 square. So we are writing it is 4k square minus 4k plus 1. Now if you calculate the sum of these terms, it is 4 into 1 by 6 n into n plus 1 into 2n plus 1, then minus 4 into 1 by 2 n into n plus 1, and sum of the 1 n times when we are doing, the value we have it is plus n. Now if we adjust these values, the answer we obtain from here, we are writing it is 2, 3. So if we are writing n by 3 common, the first term we are left with is 2 times n plus 1 into 2n plus 1. From the next term we are saying this is 2 over here, we are writing by 3 common. So we are left with is minus 6 n plus 1, and last term we are left with is 3, n we have already taken common. So if you open all these terms, you will get 2 into 2n square plus 3n plus 1 minus 6n minus 6 plus 3. So it is 4n square plus 6n plus 2 minus 6n minus 6 plus 3. So this 6n gets cancelled. From these terms we are left with is minus 1. So we are saying the final answer we obtain, it is n by 3 into 4n square minus 1. So this is the sum of this series, that is 1 square plus 2 square plus 3 square plus 5 square, so on up to n terms. Next we have this series and we have to find the sum up to n terms. Now first of all we are going to write the kth term over here. We are considering this is the first term, this whole is the second term, this whole is the third term. So the kth term tk will be 1 square plus 2 square, so on up to plus k square, and the value of this will be 1 by 6 into k plus 1 into 2k plus 1. This is equal to 1 by 6 into 2k cube plus 3k square plus k. So this is the nth term in this case. Now we have to find the sum. So we are talking about 1 by 6 into 2 times sigma k cube plus 3 times sigma k square plus sigma k. Now we have to calculate the sum over here. So we are saying it is 1 by 6 into, first value it is 2, sigma k cube it is 1 by 4 n square into n plus 1 square plus 3 1 by 6 n into n plus 1 into 2n plus 1 plus 1 by 2 n into n plus 1. These are the values we have. Now this is 1 by 2, this is 1 by 2 and this is 1 by 2. Now if we write 1 by 2, this is 1 by 2 common, it becomes this, then n into n plus 1 common, we are left with this n into n plus 1 plus 2n plus 1 plus 1. This is n square plus n plus 2n plus 2. This is n square plus 3n plus 2. This is n plus 1 into n plus 2. So the final answer we obtain, this is equal to 1 by 12 n into n plus 1 square into n plus 2. So this is the final answer we obtain in this case. This is the sum of the first n terms. Next is prove that this value is equal to 3n plus 5 divided by 3n plus 1. Now if we look at this numerator part, we are talking about this numerator part, the general term over there, we have it is 1, 2, 3, this term it is 1, 2, so on up to n. So it is k we are having, then we are having multiplied with the 2 square, then 3 square, so on up to plus n plus 1 square. So we are saying this is k plus 1 square is being multiplied. This is the numerator we have, general term for the numerator, and for the denominator the general term we have it is k square into k plus 1. Now if we have to calculate the sum of the numerator and sum of the denominator, then what we have to do? We have to calculate the sum of all these values and we have to divide these values. One thing you should keep in mind, you are not going to write it in the form k into k plus 1 square by k square into k plus 1 sum, because this thing will mean that after dividing the values we are taking the sum, whereas we are saying the general term for this is this and we are having the sum of these terms, then we are having the sum of these terms. So these terms you cannot cancel out. So what we obtain from this is, if you solve this, you will get it is k cube plus 2k square plus k, this is sum of these terms, divided by sum of k cube plus k square. So the answers we obtain, sum of k cube it is 1 by 4 n square into n plus 1 square, then it is plus 2 into 1 by 6 n into n plus 1 into 2n plus 1, and last it is sum of k, it is 1 by 2 n into n plus 1 divided by sum of k cube, it is 1 by 4 n square into n plus 1 square plus 1 by 6 n into n plus 1 into n 2n plus 1. Now from this term we are saying, if we write 1 by 12 n into n plus 1 common from the numerator, we are left with this 3n into n plus 1 plus 4 into 2n plus 1, and last it is plus 6 divided by, from the numerator we are writing 1 by 12 n into n plus 1 common. From the first term we are left with is 3n into n plus 1. From the second term we are left with is 2 into 2n plus 1. These two terms gets cancelled. Now if we simplify further these values, we obtain this is equal to, it is 3n square plus 3n plus 8n plus 10 divided by, in the denominator we are left with is 3n square plus 7n plus 2. So this is equal to 3n square plus 11n plus 10 divided by 3n square plus 7n plus 2. So if you factorize this numerator, it is 3x plus 5 into x plus 2. If you factorize this denominator, it is factorized as 3x plus 1 into x plus 2. So x plus 2 gets cancelled and we are left with this answer, that it is 3n plus 5 over 3n plus 1. So this is the required value. Now next we have to find the sum of this series. So first of all we are writing the general term tk. So we can see that the terms over here they are, it is 2, 5, 8. So we can write it is 1 over 2 a plus k minus 1 into 3. This is the general term over here, multiplied by 5 plus k minus 1 into 3. So we are writing this is equal to 1 by, when you solve this value you will obtain 3k minus 1 into 3k plus 2, and by using the partial fractions we can write this is equal to 1 by 3 into 1 by 3k minus 1 minus 1 by 3k plus 2. So this is the value of tk. Now if we write t1, that is equal to 1 by 3, 1 by 2 minus 1 by 5. If we write t2, it is 1 by 3 into 1 by 5 minus 1 by 8. If we write t3, it is 1 by 3 into 1 by 8 minus 1 by 11. And the value of tn we have, it is 1 by 3 into 1 by 3n minus 1 minus 1 by 3n plus 2. Now suppose we add all these values, we are saying t1 plus t2 so on up to tn. What we obtain, 1 by 5 gets cancelled, 1 by 8 get cancelled, likewise all these terms they will get cancelled, and what we are left with is 1 by 3 into 1 by 2 minus 1 by 3n plus 2. So it is equal to 1 by 3 into 3n plus 2 minus 2 divided by 2 into 3n plus 2. So this is equal to, these 2 gets cancelled, 3 gets cancelled, we are left with this n over 2 into 3n plus 2. So this is the sum of this series. This is the sum of this series. Next is find the sum up to n terms of the series 5 plus 11 plus 19 plus 29 plus 41 so on. So if we look at this series, it is neither a AP nor GP. So we have to calculate the sum. So we are writing let Sn is equal to 5 plus 11 plus 19 plus 29 plus 41 and so on. Now we again write Sn is equal to, we are writing it is 5 plus 11 plus 19 plus 29 and so on. We are talking about the last term, it is Tn over here, and last term it is Tn over here. Now if we subtract both these series, if we subtract both of these, we obtain 0 is equal to, we are saying it is 5 plus, now look at these terms, 11 minus 5 is 6, 19 minus 11 it is 8, then 29 minus 19 it is 10, so on up to n minus 1 terms, and last term this Tn we are left with is, it is minus of Tn. So what we get is that the value of Tn is equal to 5 plus, look at these values, it is 6 plus 8 plus 10 so on up to n minus 1. So we are saying this is equal to 5 plus number of terms we have over here, it is n minus 1. So it is n minus 1 by 2 into 2a plus n minus 1, n minus 1 is n minus 2, and the common difference we have over here, it is 2. So we are saying the value of Tn we have, it is 5 plus, now if we cancel this 2 over here, we are left with this n minus n plus 4. So the answer we are writing, it is n minus 1 into n plus 4. So this is equal to n square plus 3n plus 1. This is the nth term of this series. Now to calculate the sum of these n terms, we are saying sigma Tn, that is equal to sigma n square plus 3 times sigma n plus sigma 1. So it is 1 by 6 n into n plus 1 into 2n plus 1 plus 3 into 1 by 2n into n plus 1, and last it is plus n. Now if you solve this value, if you simplify this value, you will obtain the answer in the form 1 by 3n into 2 n plus 2 into n plus 4. So this is the sum of this series. So what we have done, we have calculated the general term by using this method, by subtracting the terms of the series by shifting them on the right hand side, and we have obtained the general term over here. Next is find the sum of the series. Again it is Sn is equal to 3 plus 7 plus 13 plus 21 plus 31 and so on. Suppose the last term we are writing it is Tn. Again we are writing Sn is equal to, it is 3 plus 7 plus 13 plus 21 so on up to Tn. If we subtract these terms, we will get it is 3 plus 4 plus 6 plus 8 so on up to n minus 1 terms minus Tn. So we are saying this method is applicable only when we are saying that the difference of these terms, we are saying the difference between these two terms, it is 4, the difference between these two it is 6, difference between these two it is 8. It is not fixed, but this forms an AP. So we are using this kind of result and we are saying this is equal to 0. So what we get is 0 is equal to 3 plus the sum of this AP, it is n minus 1 by 2 into 2 into 4 plus n minus 2 into 2 minus Tn. So the value of Tn we get, that is equal to 3 plus from here we are saying this 2 gets cancelled, we are left with this n minus 1 into n plus 2, and on solving this we obtain Tn is equal to n square plus n plus 1. Now if we calculate the sum Sn, that is equal to sigma Tn, we are saying it is sigma n square plus sigma n plus sigma 1. So it is 1 by 6 into n into 2n plus 1 plus 1 by 2 n into n plus 1 plus n, and if you solve this value, if you simplify this value, you can obtain the answer in the form 1 by 3n n square plus 3n plus 5. So this is the sum of the first n terms of the given series. Now next is find the sum of the 50 terms of this series. So we are saying, you can see the difference between these two is 1, the difference between these two is 3, the difference between these two is 5, difference between these two it is 7. So this forms an AP. So we are writing Sn is equal to 2 plus 3 plus 6 plus 11 plus 18 so on up to plus Tn. Again Sn is equal to 2 plus 3 so on up to plus Tn. If you subtract these values, you will get 0 is equal to 2 plus 1 plus 3 plus 5 plus 7 so on up to n minus 1 terms, and it is minus Tn. So the value of Tn you will obtain, it is 2 plus the value, it is 1 plus 3 plus 5, and the sum of these values it is n minus 1 by 2 into 2 plus n minus 2 into 2. Again this 2 gets cancelled, we are left with this 2 plus n minus 1 square. Now we are saying that the 50th term we have to find the 50th term of this series. So we are saying the value of T50 we have, it is 2 plus 50 minus 1 square. So that is equal to 2 plus 49 square, that is equal to 2403. So this is the 50th term of this series. Now next is we have to find the sum of this series up to n terms and up to 10 terms. So if we look at this term over here, this is an even number. So we are writing the general value of Tk, that is equal to, it is 2k cube. If you substitute k is equal to 1, you will get 2. If you will substitute k is equal to 2, you will get 4 cube, then 6 cube. And it is minus sign over here, and this term it is 2k plus 1 cube. So if you open all these cubes, you will get it is 8k cube plus 1 plus 6k into 2k plus 1 minus 8k cube, and this value comes out to be 12k square plus 6k plus 1. Now we have to calculate the value of sum of these terms, and k is varying from 1 to n. The answer we get, it is 12 into 1 by 6 into n into n plus 1 into 2n plus 1, then it is plus 6 into 1 by 2n into n plus 1, and last term we are getting it is plus n. So this gets cancelled, we are left with this 2, this gets cancelled, we are left with this 3. So if you solve this value, you will obtain that sigma, that is Sn is equal to sigma k is equal to 1 to n Tn. If you simplify these values, if you simplify, open all these brackets and simplify these values, the answer you will obtain it is 4n cube plus 9n square plus 6n. So this is the sum of the n terms. Next we have to calculate the sum up to 10 terms. So we are saying S10, that is equal to 10 into, we substitute the values over here, we are substituting the values in this formula, it is 10 into 4 into 10 square plus 9 into 10 plus 6. So answer we get it is 4960. So this is the sum of 10 terms of this series. Next is find the sum of this series up to n terms. So if we write the general term over here Tn, we are saying it is 1 cube plus 2 cube so on up to plus n cube divided by 1 plus 3 plus 5 so on up to plus 2n minus 1. Now sum of both these terms, it is n into n plus 1, it is n square and 1 by 4, and sum of the denominator, it is 1 by 2n into this value when you will solve, you will get it is 2n. This value when you will solve, this will get your 2n, 1 plus 2n minus 1. So from this term we are saying that this 1 by 2, this n is being cancelled out, and we are left with this 1 by 4, this n is being cancelled out, 1 by 4 into n plus 1 square, that is n square plus 2n plus 1. Now if we calculate the sum up to, we are calculating sigma Tn, we are saying it is 1 by 4 sigma n square plus 2 sigma n plus sigma 1. So the answer we have it is 1 by 4 into n plus 1 into 2n plus 1 divided by 6 plus 2n into n plus 1 divided by 2 plus n. And when we solve this value, when you simplify this value, you will obtain the result in this form, that is the final result you are getting, it is n into 2n square plus 9n plus 13 divided by 24. So this is the sum of these terms up to n terms. Next is find the sum up to n terms of this series. So if we write the nth term over here, this is the first term, this is second term, this is third term. So when we move up to the nth term, how many terms will be there? The number of terms that we will have, it is equal to, we are talking about the when we are talking about nth term, there will be n different values that are being added. So the total number of terms, it is 1 plus 2 plus 3 so on up to plus n. We are saying this is one term over here, then there are 2 terms, then there are 3 terms, and then there are n terms. So total number of terms we have, it is 1 plus 2 plus 3 so on up to n, that is equal to n into n plus 1 by 2. These are the total number of terms that we have over here. Now the first term in this sum, it is 1. The common difference we have, it is, we are talking about, we have 1 plus 2 plus 3 so on up to n into n plus 1 by 2 terms. We are calculating the value of this. Now we are saying this is an AP. The first term of this AP, it is 1. The common difference we have, it is equal to 1. So the value of sum of this AP, that is equal to n into n plus 1 by 2 divided by 2, these are the number of terms, into 2 times a first term plus n into n plus 1 by 2 minus 1, n minus 1, value of d is 1, and divided by this value we are having, and if you solve this result, if you solve this value, you will obtain this is n into n plus 1 by 4 into, if we take the LCM over here, we are left with this 4 plus n into n plus 1, and it is minus 2 divided by 2. So the final answer we obtain, it is 1 by 8 n into n plus 1, and this value we obtain, it is n square plus n plus 2. So this is the sum of all these terms. So we are saying the total number of terms are this. We have an AP 1 plus 2 plus 3 so on up to n into n plus 1 by 2 terms, and the sum of all these terms, it comes out to be 1 by 8 n into n plus 1 into n square plus n plus 2. Next is find the sum of this series and find the coefficient of x raised to the power n minus 1 in the expansion of this. So if we write the nth term over here, we are having 1 into n, then 2 into n minus 1, 3 into n minus 2, so on up to n into 1. So if we write the nth term over here, we are saying rth term. So that is r into n minus r plus 1. So we are saying this is equal to n plus 1r minus r square. Now we have to find the sum of this series. So sum of this series means we are calculating the value of sigma r is equal to 1 to n tr, that is equal to n plus 1. N is a constant number over here, it is sigma r minus sigma r square. So the answer we are getting in this case, it is n plus 1 into 1 by 2 n into n plus 1 minus n into n plus 1 into 2n plus 1 divided by 6. This gives us 1 by 6 n into n plus 1 common. We are left with this 3n plus 3 minus 2n minus 1. We get it is 1 by 6 n into n plus 1 into n plus 2. So this is the sum of the n terms of this series. Now we have to calculate the coefficient of x raised to the power n minus 1 in the expansion of this. So we are writing 1 plus 2x plus 3x square plus so on up to n x raised to the power n minus 1 into 1 plus 2x plus 3x square so on up to plus n x raised to the power n minus 1. Now if we write the coefficient of x raised to the power n minus 1, the value will be, it is 1. What we are saying, x raised to the power n minus 1 coefficient we want to write. So we have this term x raised to the power n minus 1. It is first multiplied with this 1. So we are saying it is 1 plus into n. The next it is multiplied with the 2. We are saying it is 2 into n. Next it is multiplied with, this is not 2 into n, this is 2 into n minus 1. 2 into the term before this. The next it is 3 into n minus 2. So on up to 1 into n, and we have seen that the sum, the value of this sum, it is 1 by 6 n into n plus 1 into n plus 2. So this is the coefficient of this term. We are saying this is the coefficient of x raised to the power n minus 1. Thus this sum gives us the coefficient of x raised to the power n minus 1 in the expansion of this whole square. If you open this whole square, this will be the coefficient.